F-18 Hornet is a very famous US strike fighter. It's used all over the world. Wow, that's a life size. Okay, so now we're at the California Science Center. Yup, you guessed it. I'm back in Los Angeles. Re-entry module, in re-entry and command module. Yeah, you can see those marks, right? That's what left with the re-entry. So, this is the Viking 1 and Viking 2 probe. There are two sister probes that land on Mars in 1967. One in the northern latitude and one in the southern latitude, but in the same hemisphere. Their goal is to find possible signs of life and water on Mars, but so this is Apollo 16. This spacesuit is from Apollo 16. Astronaut Matt. One of Apollo 16's astronauts. Okay, so this model telescope is the Chandra X-ray telescope. Launched in July 1999 on top of the Space Shuttle Columbia. Then after that, the Space Shuttle Columbia deployed the telescope into space. Then it starts observing high energy X-rays. So this is the Hubble Space Telescope, launched in the 1980s. It is the first ever space telescope to be launched into space. Okay, so this topic, the spectrum of light, at the University of Arizona at the astronomy camp, Dr. McCarthy has talked about this. So the light that our eyes can see is just a tiny portion of the entire light spectrum. So like lights can have different wavelengths. There are different wavelengths of light, like you see here, infrared, visible light, ultraviolet. So the more energetic ones are like ultraviolet X-rays. They can irritate our skin. And the lower energy ones are like infrared and radio. Okay, so looks like we have something here that can help you understand how to differentiate low energy wavelengths to high energy wavelengths. Alright, for low energy wavelengths like radio waves, you can see if I turn the crank slowly, the waves appear to be very long. So like from each peak, right, it's like a wave from each peak, there's a distance that we can measure. Like here, as I turn the crank slowly, that's the low energy wave. As you can see, the height of each wave is very long. So like if I turn faster, it means that the wave has more energy. And you see like between the distance between the waves, right, is smaller. Like if I turn faster, it means that the wavelength is more energetic and the waves are smaller. So that's a Chandra X-ray telescope, and that's a Space telescope. And that's the big one, is the Hubble Space Telescope. So, have you ever wondered why we have to waste so much money, like in millions of dollars, to build space telescopes? Because like on Earth, right, the Earth has an atmosphere. So like at the last billionth of a second, light arrives to our eyes. There are water crystals that can diffract, like refract the light, so that the light appears distorted. So like in space, there are no water crystals, there are no ice crystals, there's no atmosphere to distort the light, right? So everything is pure, directly from the object. So like we don't have to make any special adjustments to the mirror. Space Shuttle Endeavour Museum. So these tires flew to space before. There's the toilet on a space shuttle, so that on Earth there's gravity to pull the urine down, right? So like on space there's microgravity, means that liquid can easily float around the entire place, damaging equipment. So what do you mind if like urine gets into your face? So that this thing works differently. It's like there's a sucker down here. Like after you urine, you pull the flush, and the air will suck, and the sucker will suck all the air with the urine down to a container, waiting to be disposed. This is the replica of mission control back in the 20th century. Of course, the current mission control in Houston is much more modern. They replace all those computers with new ones. So the first solid rocket booster separation is in about 3-4 minutes. But I know that the external tank separation, booster separation is at 8 minutes. 8 minutes 50 seconds. But now we are going on top of a space shuttle simulator. See those two ships there? That's where we'll sit in later. Now it's occupied. We're going there at the next turn. This place is cool and amazing, especially in mission control. So this is gonna be a bit like Universal Studios. Like everything moves and then you visually see that you're going very fast. It's gonna be a bit like those kind of rides in your Universal Studios, but not that dynamic. But it's already good. Wow, the Space Shuttle Endeavour. This is the actual space shuttle that flew into space. Prepare the Hubble Space Telescope. there are 6 space shuttles. So there's Space Shuttle Columbia, Space Shuttle Discovery, Space Shuttle Endeavour, which is this one, Space Shuttle Atlantis, and Space Shuttle Challenger. And there's another space shuttle, which is the Enterprise. That is a prototype, an experimental vessel, which is not designed for space travel. Okay, so those are the 3 engines of the Space Shuttle Endeavour. So there's something special about the Space Shuttle's engines. They are the first throttleable engines, rocket engines. So what does that mean? It means you can control the output of the rocket thrust. Like for example, the solid rocket boosters. If you ignite it, it burns, it fires, you can't control it. But this one, you can control it like, you close the nozzle smaller to produce maybe 20% thrust, then you open a bit, 30% thrust, and of course you can go to 100. Then you can see those holes on the sides and that big cone beside the big engines. Those are the thrusters. So that in space there's no air. So it means that you can't use the wings to yaw, to lift. So they use the rocket engines to push, to create thrust. To maneuver around space. And are you wondering what the wings are for? The wings are for re-entry, so that the space shuttle comes down as a glider. Because at that time the engine is out of fuel, so it comes down as a glider. So there's only one shot.
There's 2 miles worth of tubes there. That's carrying this liquid 423 degrees below zero hydrogen to cool the bell. It's going flowing back through the bell, 6,000 degrees on the inside. Put your hand on the outside, not reverted. And so also has a double function. It warms up the hydrogen, so it's warmer by the time it gets into the firing chamber.
Okay guys, this is the external tank. ET-94 is the last external tank built for flight. So after the external tank is dropped off from the space shuttle in space, it burns up in the atmosphere. I think now you've been wondering why this thing is here. This thing is built for flight, but it was never launched. Of cotton candy. Wow, this is cold. So all those fabrics, right? Those are different insulators. This cold surface is for testing. It is ice cold. This is a feather. Some feathers. guys. You guys welcome back. Just exited the California Science Center, which is now closing. And look at this beautiful rose garden. It reminds me something about the White House. Wow. This is one beautiful fountain.